Welcome to Physics with Dr. T. These lab reference tools are designed to help make it easier for you to be successful when you analyze your data and write your data up into a formal lab report. So one thing that you all come in here knowing about is something called the scientific method. That's something that we use, a structure that we use to study a thing. But one of the parts of the scientific method that sometimes gets overlooked is the reporting your conclusions part. Most of you are going to go on to a medical school or maybe into some advanced education where you're going to be exposed to having to, at the very least, read professional journals where they've done scientific studies of something. You may even be asked to write a manuscript of your own based off some research that you've been associated with. One of the things that I want to do in this lab is to help you start being prepared for that, and so I've organized our report structure in the way that we have. And in this series of videos, you're going to be able to take a look at what that structure should be and have some examples of poor, average, and excellent lab reports that can help you continue to move in the direction you need to be successful at the next level. There are three types of lab reports that you will be asked to do throughout the course of the semester. There is the worksheet lab report, which is we provide you with a worksheet that you record your data on, and then you submit with your worksheet a short summary, about half a page, and we can talk about that later in the video. The second type of report that you're going to submit is the short lab report. The short lab report is an actual functional scientific lab report. You'll be given a formal structure and guidelines on how to write your short lab report so that you can submit it and have a competent and clear scientific way of presenting the evidence that you collect in the lab. And finally, you have the formal lab report, which will take place later in the semester, generally allowing you some time to develop your lab writing skills in this format, and then with a couple of extra things added, does give you some experience in writing something that's a little bit closer to what you would be expected to write for a proper journal publication. So let's take a quick look right now at the general guidelines and grading rubric that you'll be expected to adhere to for your short lab reports. So let's jump into the short lab report here. This should be found under your lab reference tools on D2L, but let's go through it point by point to just get the general idea going. So for a short lab report, remember this is a way of bringing together your ideas in a scientific way, in an organized way, so that the person who reads what you've written, so that whoever reads your report can see what you've done, understand how you got the results that you got, whether they're good or bad results, and then see about reproducing them using the guidelines that you explain in your short lab report. First thing to think about for your short lab report is that it should be professional looking. We're not in high school anymore. We're not in other activities. This is what you want to be thinking about, is the fact that eventually you're going to be writing reports for somebody for various reasons, and usually going to be in a scientific environment. So you want to use this as an opportunity to start developing those skills. So thinking about this as a professional presentation of your work is paramount. You want to have that in the back of your mind as you go. The short lab report is basically composed of four key parts. You've got your title, an introduction section, a data and results section, an analysis section, and there's two different things that happen in those two sections that is not always obvious, but we'll talk about those details in a moment. And then a discussion or conclusion. You can call it either. You can call it discussion and conclusion. The idea here is to be able to bring together your points from the rest of the part of the lab and then make a forward-looking comment about where to go next with this type of thing. So let's go through these a little bit more point by point. You see under the introduction, you're going to introduce a topic, a little bit about the science itself that supports it. Very nearly every experiment you have to work with this year will have a formula that you're testing in some fashion or another. So that formula needs to be in the lab manual. That formula needs to be in your introduction. Some people will like to put those a little bit further down, but if you introduce it right away, you can introduce it as the center point of your experiment. You are hypothesizing that this formula is a valid scientific principle, and the rest of the lab is designed to demonstrate either its success or its failure. Also, part of the introduction should have a short explanation about the procedure. You want to describe the procedure that you did or at least attempted to do. Anything that veers from that needs to be saved for a later section. Right now you're introducing the concept and you're introducing the lab activity to the reader. You can add pictures in there if you want to show a setup of your thing. You want to make sure that you're not copying and pasting from the lab manual. That will trigger the violation of the academic integrity. You need to make sure that you write your own original thoughts, and it's very important that you think about this part for the rest of these labs. If you have conversations with your lab partners about various details of the lab, it's okay to have the same ideas that are in the page, but you cannot write the same thing. You can't write word for word. You can't just copy and paste from the other person, even if you're in a crunch, because that will trigger the academic integrity clause, and we want to make sure that we avoid that. We want to make sure that you are developing your original thinking process and your way of describing things that are logical to you in these reports. The data and results section. Let's talk about what goes in here, because sometimes it can seem a little vague. Your data and results is not just, I took this data, here it is. You have to give it context. You have to talk about anything that may have happened during the lab activity that created anything unexpected. If you have a large amounts of data, you don't always want to just present all that data. You want to just take a few segments of that data and say, here's a sample of the data. That way it keeps the report from being overlong and difficult to follow with the eye. This is the section that you present tables or graphs that present the data itself. What did you have happen in the lab? You want to highlight any anomalies, anything that stands out in the data that may not be obvious to the reader. You cannot assume that the reader is going to see everything that you saw in the course of your lab activity, and so it's up to you to highlight these things. You want to say this piece of data stands out a little bit further from the rest of the trend and could have been caused by shaking of the table or other things. You don't want to get too far into analysis, but at least explaining a situation that happened in the lab that influences. An example of this might be, say you are monitoring the motion of a ball with a motion sensor, and there's this weirdness in the thing, and that would be happening at a point when a lab member bumped into the table. You want to report that. You want to highlight that an event happened and it influenced your data. So you don't want to just put in there, even if there was no influence, maybe your data looks absolutely pristine. You want to talk about any contributing factors that might even show up on a deeper analysis that may be beyond the scope of the lab. But you don't want to just put data or a table or just a sentence in that section and say, there it is. That's not a scientific approach. You want to give some context. Under the analysis section, you want to, this is the part that you dive into your data. The first question you want to ask is, does your data support the formula listed up above? If it does, you want to explain why you think so. And don't just say yes because it does or it looks nice. We want to have a justifiable way of doing that. You can refer to the statistical analysis that you can do, whether it's within 5% or outside of 5%, and discuss the impact of what that means. Did you actually demonstrate that the formula is right or wrong? Were there contributing factors that explain errors in your experiment? What was it? Did somebody come up and breathe on your lab activity and throw off your data? This is where you want to postulate possible explanations for your data. You don't have to be exactly right. The idea here is to think beyond the box, to be able to look at your data and say, did we answer the question, and can we explain why the data looks the way it does? Whether it's data in a table or data on a graph. But this all goes back to, was my lab activity valid? Did we demonstrate or prove or disprove the formula that was that this whole lab is built around? Finally, the discussion or conclusion section, you kind of do a quick recap, one sentence or two that says, we were able to demonstrate that this data was viable for one half of the experiment, but for the second half we weren't able to justify it. Whatever your explanation is, but you want to do a quick summary, and then you take it to the next step. You want to zoom out and say, okay, this lab activity overall, was it a good way to test the theory that you postulate? Was this a viable experiment, or does some changes need to be made for future experiments if you're going to test this again? Did the software have an impact? Was the equipment faulty and questionable and needs to be replaced? Was it environmental factors such as the state of the experimental space, the room? Was too many people in the lab? So you want to look for ways to explain, was this a viable experiment and should it be changed, or would there be something else that might be interesting to do? So you want to do just more than just a couple sentences. There should be a good 1 or 2 paragraphs that summarizes the experiment and talks about the experiment itself overall. There are a few other things that are in this that you want to take a look through. Presentation, all labs, this is 2022 as of the filming of this video, is 2022. Nearly everybody has a cell phone and other technology. There's no reason to be submitting handwritten lab manuals. This is an archaic practice in a lot of areas. Do not submit handwritten segments, summaries, conclusions. They should all be printed, typed up, printed. That way you've had time to think about what the experiment was before you submit it. Under style of writing, you see that it says, you are encouraged to bring your outline to review by the instructor. We are here to help you do better. We have the wherewithal. You can email a copy of your lab to your instructor, any one of your TAs, or to myself, and get some feedback to see if we have some suggestions. Take advantage of this. We are here to help you improve, and we want to help you do that. Also, we have the Physics Help Center, which is where we have physics graduate students over in ID Weeks over in the library, ready to assist you with your lab reports, in addition to any work that you may need assistance with your homework. There is a writing center also that's available for you if you want to get any practice. If you're an international student and you're trying to improve your English speaking, writing these labs can help you a great deal towards that. So take advantage of the writing center and the academic and career planning center to help support that. Most lab reports are written in the third person or in a collective point of view. So try to avoid talking about I did this, I did that. Even if you did conduct the lab by yourself, you still want to generalize it and make it more impersonal. So you want it to be, for example, you see here the speed of the ball was measured after it had fallen 1 meter versus I measured the speed of the ball after it had fallen 1 meter. The impersonal allows the reader to stay focused on the science and less about the author of the report. An important note, all variables and constants should be italicized when written in paragraphs. So just click on the little I once you highlight that term and make sure it's italics. That is a potential point loser, and which we'll go over in the next video. I'm not going to go through each of these point by point, but it is important that you understand about the title. The title and author, the title needs to be a meaningful title. Try to avoid just copying what the title of the lab is that I give you. I want to challenge you to be creative, be a little bit innovative. What is the lab that you're exploring, and what is the title that can capture the heart of that beyond Ohm's law or something like that? There are some very creative ideas that many students like to take advantage of. As long as we stay within reason and don't get too carried away, there's a lot of fun that you can have in writing original titles for your lab reports. Make sure that your name and any partner that you worked with is listed in your lab, and if it was a solo experiment, just write it. Just write that as performed as a solo experiment. The date of the experiment or the date of the submission, that's flexible. That's less important. Just want to have a date on there. So take the time to go through each of these. Just read through and look at some of the examples. The title you can see is organized and centered. Boldface, larger type. Equations are inserted into the text using the equation editor. We don't want to use pictures. Don't use pictures, inserting pictures. There is some techniques that we can we'll demonstrate to you in the coming videos on how to work with those. And so, like I said, this is worth going through and just reading it and getting a sense of things. So let's talk about data tables and graphs. There are different conventions in different publications, so you always are going to need to be aware when you're writing for your research professor or any other journal down the line. So it's important to be aware of what that journal, that particular publication is requiring of your manuscript that you submit. So the one I'm sticking with is one that shows up a lot in physics, and so we'll stick with that for here, but just be aware that they can change. Data tables are identified by Roman numerals. The I's, the X's, and things like that that you see in a lot of other places is how you want to identify data tables. You have capital T for table, and then the Roman letter, and you start obviously at 1, 1, 2, 3 as needed. You're not going to have data so involved that you need to go much beyond table 2 or 3. That may happen, but it's very rare. All tables should have a caption that describes what's in the table. The reader, any reader of a manuscript usually is going to come up to and read 3 things first. They're going to read the abstract, which you will learn about for the formal lab report. They'll look at all the figures, and they will read the tables. That's the first thing that they're going to do. And if they see something that's intriguing enough, that's when they'll take the time to read the body of the paragraph. We're going to read them all thoroughly for your benefit, but you need to be aware of how this process goes. So making these tables and graphs presented in a professional way with a clear caption that explains the content and gives it context and points to the text that says go read more about it in the text, that's the name of the game for this. Every table should have a row at the top which has your variables and units, and they should be italicized. You want to make sure that any subscripts are included there. You should have borders. You don't have to have borders. If you're savvy enough on making your table presentable without making it kind of mishmash within the rest of the text, you can explore using without tables. But it's important to make sure that you have your data organized in a nice way. What you see here, most of the time it's best if you use a center line for your cells when you write the tables, so that they're organized in a nice columnar fashion and makes it easy read. Never just throw in endless amounts of significant figures. You want to stick to maybe 2, 3 decimal places at most, because once you go beyond that, the table becomes a mess and it's really difficult to read. And you can check that out when the video that shows you the poor, average, and excellent lab reports. Figures, pictures, graphs, diagrams, these all fall under the umbrella term figures. So anything that's pictorial in any way, you want to capture or label as a figure. That way you only have tables and figures to keep track of when you're making your report. Figures should be labeled with Arabic numerals 1, 2, 3 in the traditional English way. And again, every graph should have a caption as well as a label and a reference to anything in that picture or image that you want to draw attention to, and then a reference that says talk about this more in the text, and that will guide the reader in that way. Tables should always have labels on the axes, should always have units in the labels, axis labels. It should have a title. It should have an equation and r squared. We'll talk about r squared in more detail, but basically it's a measure of the goodness of the equation that you chose to fit. There is rare occasions where a fit equation is not necessary, and that will be explained in your lab manual that it's not necessary. But unless it said otherwise, expect to have your graph to have a fit equation and an r squared value demonstrated on the graph. You can do some formatting to make it look nice, and you can shift it around your Word page to make it more manageable, but those are also questions that we can talk about in one-on-one, or if I'm able to get to making a video for using Microsoft Word. Thanks for taking the time to listen to this video. Make sure you check out the next video, which will give some examples of 3 copies of the same lab report written in a poor quality style, an average quality style, and an excellent quality style, so you can have some context on how to proceed. Unless you have any other questions, we'll see you in the lab.